Energetic Physiognomy. A very warm welcome to Deeksha Vedantu YouTube channel. I'm your master teacher Neha Ma'am. In today's session, we are going to solve the doubts regarding your ninth standard physics syllabus. Okay, so if you have any questions regarding the syllabus, regarding the any of the question, if you have doubt, you can just put your doubt in the chat section. Okay, I'm looking at your comments. So, shall we start? Let's wait for a few minutes so that students can join and they can discuss whatever the doubts they have. So, before that, is the live started? And can you guys hear me and see me properly? Uh, is there any problem with the live or can you see it properly? Right? You can see the live, right? So, yes, I think now it's fine. Okay. Okay, then we are starting with the live. Okay, so voice is fine, right? Yes, Ranjan. Okay, so yes, guys, let's start then today's session. Share the video with your friends so that they can also join the live and they can also discuss their doubts here in the live session. So share the videos with your friends. Let them also join so that if there are more doubts, we can talk about more of the concepts, right? So yeah. So yes, so everything is started properly. So let's start the yeah. Before that, let me give you a update regarding Vedantu Learning Center. So Vedantu Learning Centers are across India. You can see the places from Jammu Kashmir to Tamil Nadu, Karnataka, Telangana, everywhere across India. Vedantu Learning Centers are spread. And if you want to opt for any of the courses like JEE, NEET, and yeah, my name is Neha. Okay. So if you want to opt for any of the courses like JEE NEET Foundation, you can walk through the learning centers. So do go and check out that. You'll get the link in the description box, right? So you can go with the link also, or else you can call the number given on your slide and you can inquire regarding the courses, course details, whatever you require. Okay. So this was a quick update regarding Vedantu Learning Centers. So good faculties, good infrastructure, good place. You'll get to learn the things, right? So do check it out. And stating this, shall we start the session or let's wait for a few minutes so that those who want to join the session, they can, right? So share the sessions with the 9 students. So as their exams are not done yet, I'm conducting this session as a complete revision for your ninth physics, right? So quickly share the videos with your friends and then we'll start the session. Okay. So is that clear with everything? So you have 5 chapters from physics, right? In your science examination, you'll be having 5 chapters from physics, motion, then work, power, energy, gravitation, sound, and the other one was yes, motion, work, power, energy, gravitation. Yes, so you have totally 5 chapters. Is that clear? So if you have any doubt regarding your ninth syllabus, you can just put it in the chat. Let me just take you through the chapters. So wherever you feel difficulty, you can ask me to explain once, right? So yeah, so let the students join. Let me start with the first chapter, motion. Okay, after that we will move to the rest of the things. So I'll be just giving you the overview. Okay, I'll be just giving you the overview. Just a second. Let me just present this. Yes, I'm just giving you the overview of all the chapters that exist in your physics. Okay, let's start with the motion concept and let's move further with all the other chapters. Everything is clear? Good. So, yes, so keep asking your doubts within the session. I'm ready to solve your doubts, right? So, starting with the motion chapter, before moving ahead, those who are new to the channel, do not forget to subscribe the channel. You are going to get great content on this channel regarding your ninth, 10th foundation courses and etc. So stay tuned with the channel. If you like the video, don't forget to hit the like button and let's dive into our session now. Okay, so just quickly going through all the chapters, starting with motion. There are different kinds of motion. In your chapter, first we are discussing about a motion in a straight line. Nothing but if a particle is moving in a straight line, we call it as motion in straight line. And then we will be understanding about circular motion. So these concepts are in your first what is ninth standard chapter. Okay, so knowing about different kinds of motion, there are motion in one dimension, two dimension, three dimension. If you have already watched my session foundation course on the chapter motion, where I have discussed these all kinds of motion in very detail. Okay, but in your ninth standard you just have motion in one dimension, starting with rest or motion. Okay, so, what is rest or what is motion? So, stating that they are the relative terms. Relative terms means there is nothing like absolute rest or absolute motion. It is just from the frame of reference or from the point of view where you are seeing that objects. Okay, so it is dependent on that. Clear? So, this is just about the knowledge. You will not get any questions from there. Just you have to know what is the things going on in our surroundings. So what is motion? Moving forward, motion is nothing but movement with respect to time. If anything is moving with respect to time, we call it as motion. And what is frame of reference? With respect to a point, if you are describing the location of other point, likewise you are locating your home with the landmarks, right? So that is an example for reference point. Clear? So, sorry. So this is about the reference point concept. Again, there are no direct question from this concept. Moving forward, distance and displacement, important concept. You must know what is the what is distance, what is displacement, and also the difference between them. Okay, so stating that distance is nothing but the total path covered by an object is called as distance. If somebody is moving all the way along and he is coming back to the point, we will measure all the way he had walked through. Okay, so that total path covered by an object is called as distance. You can just see in the example, the girl is moving from her home to the tuition and then she is returning to her home. Okay, so the path she took is considered to be distance, but irrespective of the path, if I find out what is the shortest distance between her home and the school, okay, so that will be a perpendicular straight line joining the 2 points, right? So that is displacement. So knowing about more about distance is path dependent. Distance depends upon the path what you choose. Okay. Distance is also called as it is a scalar quantity. Scalar quantity nothing but the quantity that has only magnitude but no direction. Distance you'll not specify as it is east, west or any other direction. Here we just consider to be the magnitude. Yes, hi, Mountver. Hi. How are you? I'm good. How are you? How is everything going? Studies and all? I'm good. Okay. So, any doubts from these chapters, you can ask me, right? So, this is a doubt solving session. Share the videos with your friends so they can also join and clear their doubts. Fine? Yeah. So I was telling about distance, right? So, and also as distance is a scalar quantity, it is always constant. It doesn't mean that scalar quantities are always constant, but here we are considering it to be a constant positive quantity. So what does it mean? You choose the direction right, you go left, whatever direction you go, Okay, it is not concerned about that. Whatever direction you choose, we are just considering the magnitude, right? If a person is walking 5 kilometer in this direction, okay, and then he feels that he want to go back to his home, so he walks more than 10 kilometers, let's consider. So what is the total distance, if anybody asks that? So what will be the total distance? It is just 15 kilometers, because we don't concern about whatever the direction is, we just concern about the magnitudes. Clear? uh yes, they are going to conduct fun session, but it is not yet clear. I have spoken regarding that. Okay, they are planning but not sure yet. If there will be fun session, that will be updated on the channel. You can easily know that, it's not a big deal. Okay, you can easily know that that will be updated in the channel. Okay, so path dependent, it depends upon the path, the way which you walk instead of the direction. So scalar quantity and always positive. As I said, direction does not matter. If somebody is walking for, as I said, this direction and then again this, so we don't concern about that, we just add the magnitudes. Let's consider a b c were the magnitudes, we are going to add them just as it is. Clear with this? So you should know this regarding the distance. Let's move forward, as it is not a complete concept explanation session, just glancing over the topics so that it will be helpful for your ninth CBSE board or whatever the exam you're attending for. As such, you said me your exams are going to be held, right? So I'm just taking this session. The shortest distance between initial and final point is called as displacement. As I said, if there is a initial point, let me call it as A, and there's a final point, let me call it as B. And what is the shortest distance between 2 points? It is the straight line joining them, and here direction is mandatory. So if the person is walking whatever the route he wants, but we will consider only the point, only the line joining the shortest distance, that is the perpendicular line between 2 points. And here, as I said, direction is mandatory. So direction is important. So this is path independent. It does not depend upon whatever path you choose. It does not care about that. It just cares is the shortest distance. And this is a vector quantity. As direction is important, displacement has both magnitude and direction. So it is called as vector quantity. Clear with this? So as this is a vector quantity, yeah, I just simply removed it. So as it is a vector quantity, direction matters here. So you can consider one direction. If I consider this direction to be positive, so the other direction will be negative. Okay, so how this works? Now, if the same person, right, he is walking 5 kilometers in this direction, then he is returning with the 10 kilometers. Okay, so that yields in plus 5. I'm considering this direction to be positive. So it is plus 5 minus 10 yielding minus 5. That is the displacement. If it is distance, if somebody asks what is distance, distance is 15 kilometers, but displacement is minus 5 kilometers. Is it clear? Right? Is that clear to everyone? Yes, Karnataka board is still not completed. And do you have, I think you have languages right now, right? But science, maths, the main subjects are completed. In circular path of radius r by subtended angle theta at a center, then what will be the displacement AB? You're asking me what will be the, if I consider this is a circular path, and like this, are you asking me if it's substance angle theta, person moving from A to B? Is this the question what you are asking me? Confirm it once. Pankaj, confirm this to me. Okay, Mount Ver, I got it. I was just not feeling to wear it as it's summer and all. Yes, Hindi and Kannada is the main. Okay, Pratyush, can you tell me when is Hindi? Got it? Yeah, this is the question you're asking. See, so what is the displacement here? You can go with the right angle triangle, right? So if I want to get a shortest distance, let me state this. If I get a empty slide, let me explain it here. Okay. So see, I'm going to explain it. Let me consider the scenario. First condition, a man is walking on a circular track from point A to again he is reaching to the final point B in the same point. Okay. Oh, tomorrow you have Hindi. Oh, so sorry for that. If I would have known it before, I could have done something, but it's already the time's up, right? I was thinking that if it is possible, I could have taught you Hindi, you guys Hindi. Okay, but it's tomorrow, then yeah, sorry for that. But still, Kannada is remaining, I guess. Do you want me to pronounce your name? Mountver, right? Okay, guys. So concentrate here. I was giving you the examples of circular motion, right? So sorry, Pratyush, for that. I would have planned early so I could take today Hindi session in the Kannada channel. But sorry for that. And yeah, study the Hindi, right? Tomorrow you have exam. What happened? It's not right. Sorry for that. So see here, guys, concentrate. If I lose this so I couldn't answer the question what it was. Okay, I got it now. It's Munawar, right? Okay. So see here, if a person is completing one circular complete circle, okay, can anyone tell me quickly in the chat what is the displacement of an object? I'm writing it distance. Displacement. Quickly tell me in the chat. The first diagram what I have drawn, the person is starting from the initial point is A and the final point is B. So what is the displacement of the person? Quickly tell me in the chat. Displacement of the person. Quickly in the chat. So who was asking that doubt? Pankaj Kumar, right? So yes, it is zero. Exactly. Very good. So now there's other question here. Same circular track. Okay. Now the person is moving from this point A to this point B. What is the displacement? Can you tell this? Yeah, yes, zero. Yes, zero. Pankaj, I got it. So what is the displacement in this second condition? What is the displacement here? And let's consider the third condition, what you have asked. This is the third condition, what you have asked. What is the displacement in the second condition? Quickly. Yes. Can it be more clear? Can it be more clear? What is AB? What is AB to this circle? AB is nothing but the double of radius that is called as diameter of the circle, right? So I can say it as 2r. Nothing but diameter of the circle. Okay. So moving forward to the third condition. Yes, exactly. Diameter. You're asking me displacement present here, right? So what I have did, I just joined the points. I had just connected the points with the center. This is A, this is B. Just joining all the points. What I can find here. So if I consider this to be a right angle triangle, okay. So if I consider this to be a right angle triangle, then the hypotenuse gives me the displacement. Clear? So I can consider the displacement square because the formula is hypotenuse square is equals to square of the opposite side plus square of the adjacent side. Right? I'm just using this, considering this to be a right angle because, yeah, because two radiuses are nothing but perpendicular to each other. Right? So d square is equals to r square plus r square. So finally, what is the displacement? Displacement is root of r square plus r square, nothing but root of 2r square. Further, it can be reduced as root 2 into r. Right? So this is the displacement. Is it clear now? Is this clear? Considering this to be perpendicular. Fine? Okay. So zero displacements and all. Clear. Good. R root 2 only exists case not I'm asking. Okay. Okay. You're asking for the value theta. Fine. Just a second. Let me solve that. So you're telling me there are 2 points that are making an angle theta. Okay. So what is the displacement? So if it's a right angle triangle, that was easy. But let me check it and tell you. If it is theta, then just a second. See here, it again gives the diameter of the circle. Okay. Okay, this goes to the other concept, right? So it goes to the concept where you study, you should go to mathematics for that. You'll study the arc length, right? It is called as, you know, this points in your mathematics, I guess. So you should use that concept over here. Yeah, I got it. I said, no, you should go that in mathematics, we study these kind of things, right? The arc, right, the arc length or the things like that, you should use that concept over here. I don't guess for 9th standard they'll be asking these kind of questions. If you have studied that in mathematics, so that's other condition. Clear? It's called as, yeah, I have just read it in my schooling or somewhere. It's, we call this line as something and we'll find that value, it is in mathematics. But that kind of concept, that much application in math of mathematics is not asked in the physics. Okay. So yeah, moving forward. NTSC, I got it because in just 9th boards they'll not ask these kind of questions. In NTSC they may ask. Okay, I'll check for that. The max is used here. Okay, that arc length. I'm just not a minor arc, major arc, something like that. Okay, you can check the max once. If you get there, there will be, okay, there will be something to find this length in the mathematics. So if you go with that, you'll get to know 2r sine theta by 2. Okay. Yes, we'll check for that. Sine theta is nothing but opposite by hypotenuse, r by d. D is equals to r into sine theta. But 2, how come? So we'll see for that, okay? Circle theorem. Okay, it is called as circle theorem. In that it is given 2r sine theta by 2. Okay, so if I take with my knowledge of sine theta, if I take sine theta here, it will be like opposite by hypotenuse, right? So yeah, we'll check for that. Okay, I'll check with that. Moving forward with the concepts, that is uniform and non-uniform motion. Okay, so uniform motion is nothing but if the object is covering equal in distance in equal interval of time, it is called as uniform motion. And non-uniform motion is nothing but object covers unequal distance but in equal interval of time. Again, you should not use here unequal, okay, in equal interval of time. So remember this. As you guys said that you have your 10th boards, I yes, sorry, ninth boards. Is it not completed yet? So I'm just taking the session here now. Okay, so what is speed? Quickly, just going through the topics. Rate of change of distance is called as speed. As distance is a scalar quantity, speed is also scalar quantity. And speed is also always positive. SI unit is meter per second. So if the formula to calculate the speed is, you can just U is equals to distance by time. D by T or S by T. You can use this formula to calculate speed. Okay. So then comes the average speed and instantaneous speed. If an object is moving, if a vehicle, let's consider, is moving from here to here, what is the average speed over this distance, right? So just we will add the total distance, right? Adding total distance by dividing it with total time gives us the average speed. But what about instantaneous speed? If I want to calculate the instantaneous speed at any instant, okay, vector no, vector is velocity at any instant, it is nothing but the small d by dt. Okay, ds, let me call it as. This is at a particular very short interval of time. In particular, some seconds, if 5 seconds, what is the distance? What is the speed? If they ask, you should go with instantaneous speed. So you can see it's just total distance by total time. Instantaneous speed is speed at particular time, right? Okay. So I'm not going in the depth or in all these questions. I'm just giving you overview. So the vehicle is starting from 2000 to 2400 kilometer. Nothing but the distance traveled by the vehicle is 400 kilometers. And it is given the time taken to complete the trip is 8 hours. So calculate average speed. So you know that average speed is equals to total distance covered by total time. You can just do 400 by 800, right? So it is 100, 4 twos are, it is 50, right? Kilometer per hour. You can calculate these things, then convert it into meter per second. Sorry. Velocity is nothing but rate of change of displacement. It's a vector quantity. It can be positive, negative, or zero. Okay, it's not always positive. It can be positive, negative, or zero. And again, the SI unit is meter per second. So what is velocity? Velocity is displacement by time. Yes, what's the question? So velocity is displacement by time. Okay. So yeah, what is the question? A body travels along the circular path of radius 70 centimeters. So there's a radius which is 70 meters after traveling half of the revolution in 20 seconds. So it is completing half circle in 20 seconds. Yes, what is the question? I'm asking you. I have a question. I have a question. Then what is the question? Type it down. Okay. Average velocity. So what is average velocity? The total displacement, right? What is the displacement? 70 plus 70, 140 divided by the total time, right? So you'll get the average velocity, which is, yeah, 2 8s are right. 2 sevens are 40. So 7 meter per second is the answer. And what is speed? Speed is nothing but this path, that is 2 pi r. 2 into 22 by 7 into r is 70. So 7 tens are 22 and 22, 44 0, 44 0 by 20. I'm just solving this very quickly, okay, because it's not the explanatory session. Okay, let's move to the next question now. Whatever the questions, yeah. Moving forward with the next question. Okay, let's move to the next question. Okay, a biker moves with a speed of 30 kilometer per hour for 15 minutes, or this is a complex question. Okay, just a second. Okay, so again, I'm not diving into the complex questions. That is time ticking, as this is just a doubt session. It's not a complete marathon, right? So what's acceleration? Acceleration is nothing but the rate of change of velocity. If velocity is changing with respect to time, then we call it as acceleration, right? So what's the SI unit of acceleration? Meter per second, right? Is it clear? Deacceleration, retardation, nothing but if the object is stopping after some time, so we call it as negative acceleration because the velocity is decreasing gradually. And going forward, okay. So you know the graphs, right? Just a second. So yes, moving ahead. We know the velocity time graph, distance time graph. In velocity, the slope of VT graph gives acceleration. So remember, this is important. Slope of VT graph gives acceleration, and area under VT graph gives the displacement. Can you see me properly? Okay, what happened? Just a second. I'm just checking with this. Yeah, can you guys see me properly? This channel is to teach in English, right? So we'll be a communication language will be English. Okay, is that clear? Okay, guys. So you know the laws of equations of motion, right? So that is also important. Let me just write it down over the slide. So the important laws of equation is, yes, hello, hello, hi, hi. So the first law of equation is V is equals to U plus AT. Hi, hi, Arun, Army boy, everyone, hello. V is equals to U plus AT. S is equals to UT plus half AT square. And the third equation is V square is equals to U square plus 2AS. Right? Is it clear to everyone? So these equations are important. So just be seeing at that. Okay. Done. Is it clear? So these are the important things you have to remember, and the derivation of these equations are also extremely important. So just remember them. Then comes the concept of circular motion. Right, circular motion is nothing but if an object is moving in a circular path having constant speed, same speed, nothing but uniform speed, but its direction will be changing continuously. So those kind of objects are called to be in circular motion, and the formula is V is equals to 2R by T. So yes, everybody done with the lunch? Oh, sorry, dinner. Again, I'm telling lunch. Done with your dinners. So yeah, any questions? Any ninth standard students? If you're here, if you're attending your boards, nothing but the school exam, you can ask your doubts. Okay. And yeah, the 10 pass out students, the foundation series are going on. So join there whenever we are in live. So the sessions will be interactive and good. Okay. Then, so force, the next concept. Yeah, I was just uh, forgot this name, force and laws of motion, the second chapter, right? So what is force? If you are pushing something, if you're pulling something, so you apply force, that is nothing but the force concept. Force is an effort to change the state of, so if I apply a force on any object, what happens? One thing, its speed will change, its direction will change, its shape will change, shape of the body, and yeah, so these are the important things you should know. The thing that is in rest can come into the motion. The moving object can be stopped by the application of force. Different types of force no needed. So frictional force important. What is frictional force? If something is moving forward, right? If two objects or two bodies are in contact with each other, so we whenever you feel, okay, let me just choose this pen, whenever you feel an opposition force, right? So those kind of forces are called as frictional force. Example is, if you're cycling on a ground, there is a friction between the tires and the ground, right? If you are moving forward, the frictional force will be acting in the opposite direction. It's called as the stopping force. Yeah, what is the question? Clear with this? Okay, the push or pull of an object is called as frictional force. So we come across two types of forces. One is balanced and other one is unbalanced force. Balanced force is nothing but if an object is, if we are applying two sides, okay, opposite sides with the same magnitude of force. Equal and opposite force are acting on a body, so that is called as balanced force. Yes, hello. Okay. And what is unbalanced force? If there is only, or else if there is 200 Newton in one side and 100 Newton in other side, so you can see that there is no same numbers, right? They are unbalanced. Yeah, what is that? Third equation, first question. What is that? Okay. So with this example also you can see here the people are applying 3 Newton, 3 Newton. So this rope will neither move this words or this words. So because it's a balanced force here, right? It's a balanced force over here, and here there is unbalanced force as there is 100 Newton and 300 Newton. If there is difference in the force, so that is called as unbalanced force. Yes, what's that question? So yeah, and also, if they ask you to write the difference between balanced and unbalanced force, you can write that equal strength, opposite direction. Yeah, there will be questions from third equations also. Okay. So if they ask you total net force over the balanced force will be zero, no net force, because from both the direction. Yes, Money, now you joined. You were only asking for the doubt session, right? I said you at 9 p.m., right? Why late? So here there will be net force. Balanced force do not cause change in the motion, but unbalanced force cause the change in motion. If two people are pulling this object with the same force, it will not move. If one is applying more force, then only the object moves, right? So diving more, inertia, right? Inertia is nothing but the property of the body, the tendency of the body to resist its motion. It wants to be in its position, right? And you can see the best examples. The person standing on a moving vehicle, if the vehicle suddenly stops, what happens? He falls forward. If the vehicle suddenly starts moving, he will feel the fall backward direction. Yes, Money, I'm here to tell the doubts, solve the doubts itself, right? So I was telling that. But let's go in a flow, right? So mass, if mass is more, inertia is more. Just remember that mass and inertia are directly proportional to each other. Big objects have more inertia than small objects. So that's of Newton's first law of motion regarding the inertia. It is called as, yes, about sound. I am coming. Just now you came, right? So a body continues in the state of rest. If a body is standing, book on a table, and the earth moving around the sun are examples for rest and uniform motion. Okay, so these things are important. Okay, so this is about first law of motion. Then is second law of motion, which states that F is equals to ma, right? Mass accelerations are equal to the force. So this is important. F is equals to ma. Done with these concepts. Okay. So let's dive to the next chapter then. So we are done with motion, and yeah, quickly going through the work energy, and then we will move to with the sound chapter. So what we see in work energy, different kinds of work done, right? Positive, negative, and zero work done. So what is work done? Work done is nothing but, just let me choose the pen. Work done is nothing but force into displacement is called as work done. And there are different kinds of work done present here. That is, yeah, positive, negative, and zero work done. Let me just take it here. Yeah. So work done is not only F into S, it is Fs cos theta. Cos 0 is 0. So whenever the angle between the force and displacement, okay, whenever the angle between force and displacement is 0, so we get 0 work done. If the angles are perpendicular to each other, we get Fs, right? So you can see that. So Ronaldo kicking a football is an example for positive work done, right? And you are sitting in a place and you are studying continuously. So this is example for zero work done. And if a person is catching the ball, his hands will move in backward direction, right? So the work done here is negative. Moving forward, carrying, just holding, she's lifting the heavy box and she's moving forward, right? So this is an example for zero work done. And here the work done is negative because he is applying force in one direction. So he is applying force in this direction, but the vehicle is moving in this direction. Both are opposite, 180-degree. So it's negative work done. And this is an example for positive work done. You can see that Dhoni is just hitting the bat with the ball with the bat, right? So it's moving in the direction of force. So it is an example of positive work done. So different kinds of energy. Kinetic energy is nothing but the energy possessed by an object by the motion of objects, half of mv square. And potential energy is the stored form of energy, which is equals to mgh. Done with this. So then we have work energy theorem, which is important. We know that work gets converted into the form of energy, right? We have seen this. Done then the concepts of work energy. Okay. So yes, starting with the sound. What is the doubt now in the chapter sound? What is the doubt in the chapter sound? Quickly. Yes, sound is a form of energy. Sound is a form of energy that creates sensation of hearing, right? Sound waves are mechanical waves. That means it require a material medium to travel, right? It cannot travel without the material medium. Yes, Mani, you were asking me about the doubt and sound, right? So now you can ask that. So how is sound produced? Sound is produced by the vibration, right? Whenever we speak also, due to the vibration in the vocal cords, the sound is produced. And how does it propagate? It propagates from one particle to other. So the particles present in air just vibrate about their mean position, and energy is transferred from one particle to other. In such a format, we can hear the sound. Clear? Next, we come across types of waves. There are different types of waves: transverse wave and longitudinal wave. Transverse wave is nothing but which travel in the format of crust and trough, is called as transverse wave. Longitudinal waves are the waves that travel in the format of compression and refraction. Okay, so our sound wave is an example for longitudinal wave, and light wave is an example for transverse wave. So quickly, whatever the doubt you have, you can ask that. Moving forward, sound can be visualized as the propagation of density variation. As I said, the energy is transferred, not the particles, right? So whenever we see the density propagation, so you can see at some region the particles are near compressed, and in some region the particles are apart. Okay, so this is called as density propagation. There is, so you can see the density more at a place, that is called as rarefaction, and less density in some region, that is called as, sorry, this is called as compression and this is called as rarefaction. So yeah, this is how the sound waves propagate: compression and rarefaction. Characteristics of sound waves, that is also important. So what is wavelength? Wavelength is nothing but the distance between two consecutive compression and rarefaction is called as wavelength, and its SI unit is meter. Okay, so if okay, instead of transverse wave, let's consider the longitudinal wave itself. So this is compression, here we have rarefaction, and again compression and rarefaction. This is how the wave travel, right? The distance between two consecutive compression or rarefaction is called as wavelength lambda. So the change in density from maximum value to minimum value again to the maximum value makes one complete oscillation. So one complete oscillation is maximum to minimum and then to again to the maximum. So what is frequency? Frequency is represented with nu. What is frequency? Frequency is nothing but the number of oscillations, right? The number of oscillation per unit time is called as frequency, and the SI unit of frequency is hertz. Time period, the time taken by two consecutive compression and refraction is called as time period. So you can consider time period is nothing but the reciprocal of frequency. Frequency is number of oscillation per second. Time period is the one or time required for one oscillation. So it's the period. Okay with this? Moving forward, we have loudness, softness, right? So if the amplitude is nothing but the maximum sound or the maximum deflection. Okay, so that is called as amplitude. If the amplitude is more, then the sound is said to be more loud. If the amplitude is less, it is said to have less sound. So this is about amplitude. Yes, if there are any questions, just put it down because I'm going to complete the session now. 10 syllabus, I am doing it for, right, for the 10 students. Is the ninth exams done? Light, there are already many sessions in the channel, I guess, right? You can follow up with the videos that are already existing with the channel, as we are starting the foundation course for the 10 pass out students or the one who are entering to the 10th also. Fine. So if you want light chapter, you can just go through the channel, you'll get the chapter. I've already discussed regarding the chapters. Okay, clear. So loudness and sound softness. Loud sound can travel larger distance. You know that if there is anything which is producing sound, as it moves away, if somebody who is standing very far from that point will not hear the sound rather than the person standing near it. Why? As the distance traveled by the sounds, with the distance, what happens? Sound reduces. Okay, sound reduces as the distance increases. So just remember that. A sound wave spread out from its source. Okay, as it moves away from the source, its amplitude as well as loudness decreases. That is what I said. As it moves away, the loudness or the amplitude of the sound decreases. So the quality or the timbre of sound is nothing but it is also a characteristics which distinguish a sound which has the same pitch and same loudness. The sound which is more pleasant is said to be rich in quality, which is good to hear. If the sound has single frequency, it is called as tone. If the sound which produces due to the mixture of several frequency, we call them as note, mixture of several different frequencies. That is also pleasant to hear, but noise is the unwanted sound which is not pleasant to hear. Music, pleasant to hear, rich quality of sound. Done. So yes, I'm going to wrap up the session after this sound chapter. So whatever the doubts you have, ask it quickly regarding your ninth standard physics. So speed of sound is defined as the distance which a point. So speed of sound is nothing but the speed in which the sound is traveling. And how to calculate it? It is just V is equals to lambda, nothing but the wavelength of the sound into mu, that is frequency. So this is the formula to calculate the speed of sound. So you can see the speed of sound in different mediums. So we think that speed of sound is more in the air medium, but the speed of sound, yeah, so you can see refractive index is more over here, right? You can see the speed of light. Okay, this is speed of light. Don't consider this. Speed of light is more in water or the solid mediums rather than air. This is speed of light. We are not speaking about this. We are speaking about speed of sound. So let's ignore this table. Speed of sound is maximum in the solid medium. Clear with this? Then the concept we have is reflection of sound. as you study reflection of light in the 10th standard, here we have the concept of reflection of sound. Sound also gets bouncing back. Okay, bouncing back process. This is nothing but the reflection. Bouncing back from of a sound from solid or liquid surface. So that is called as reflection. So what is echo? It is also a kind of reflection of the sound, and echo is the sound caused by reflection of sound waves from the surface back to the listener. So how it works? The brain has persistence of the sound till zero point 0.1 second, right? So after zero point 0.1 second, if we hear that reflection again, we can distinguish the both sound, and it listen we can listen it in the format of echo. But reverberation is the repeated reflection. It will not give the gap of zero point 0.1 second also. So repeatedly, we'll be hearing the sound, the reflection of sound. So this process is called as reverberation. And in the studios, in the what you can say auditoriums and all, we generally see sound absorbent materials that are used to that which absorbs the sound to stop or to reduce the reverberation, echoing effect. Right? Then we have use of multiple reflection of sound. The reflection of sound is used in megaphones, loud phones and all, just to increase the volume of sound and make it flow in one particular direction, right? So we'll be using the sound waves here. In the stethoscope, medical instrument, doctors will be using to listen to the heartbeats or the lungs of the patient, right? Sound, the multiple reflection of sound concept is used in the stethoscope. The concert ceilings, so as I said, in the ceilings of in the theaters, right? So everybody who is sitting in the halls should listen to the voice, right? So they will be making the setup in such a way that there is reflection of sound and everybody can hear the sound properly. Okay, so yeah, range of sound. So the audible range of sound is from 20 hertz to 20 kilohertz. That is what human beings can hear. As I have already taught the session, again I'm not going diving deeply. So if the frequency of sound is less than 20 hertz, it is called as infrasound or infrasonic sound, which rhinoceros, whales and elephants can hear that sound. The frequency more than 50 kilohertz is called as ultrasonic sound or ultrasound. Dolphins, bats, and other families of moths can hear this sound, but these sounds are not audible to human ears. Human beings can only hear sound from 20 hertz to 20,000 hertz. Okay. Applications of ultrasound. Ultrasound is generally used to clean the parts that are located like hardwares, electronic parts which are small, which is difficult to clean. So there ultrasounds are used, and ultrasounds are used to detect the cracks that are present in the metal bodies, and they are also used to reflect the images of heart, that is called as echocardiography. So echocardiography is an application of ultrasound. Okay. Ultrasound scanners is also an example for this. Ultrasound may be employed to break stones that are formed in kidneys. So it is also helpful to break the kidney stones. Applications of ultrasound important. If they ask in your exams, you should be able to write this. Moving forward, sonar. What is sonar? Sonar is nothing but sound, navigation, and ranging. So it's a device to range the underwater objects. It may be the mountains or the depth of the ocean or whatever the objects that are present in underwater. So detect that kind of object, sonar is used, and you know the process, right? So sonar will be having one detector, emitter. Emitter will emit the sound waves. After reflection from that object, the waves are detected by the detector, and the imaging process is done with the help of sonar. Moving to the last concept, that is human ear. So what is the structure of human ear? You can see the outer structure, which is called as pinna. Then there is ear canal, where the sound flows through the eardrum, which vibrates and produces sensation of hearing, that is sound, right? So auditory nerve, which transmits the sound signals to our brain, right? So it is called as auditory nerve. And yeah, these are the parts of human ear. So, yes, is the session clear? Is your doubts clear? Tell me quickly. I'm going to wrap up the session now as we are done with the revision, the session. Is it clear to everyone? Is the concepts clear? Tell me quickly. Are the concepts clear? We are done with the session. So, shall I wrap up the session now? So, I hope every doubts are clear. So, still, if you have anything, you can just put it in the comment section. And yeah, this was about the session. So, yes, thank you so much for watching the session and moving forward. I hope everything is clear. So, yes, this was about the today's session. Thank you so much for watching the session. Let's meet again in the next session. Till then, have a great day and bye bye.